Okay, we're gonna do some example problems from chapter 3, section 3. So you know how to solve problems for free fall. And there are only two types of problems. There's the type where something gets dropped, and there's the type where something gets thrown or kicked upward. So this is the first type where an object is dropped, and I'm just going to draw a picture to go with it. So we have a brick that's being dropped from a high scaffold. So it's not moving to begin with, and then by the time it's about to hit the ground, it's going really quickly. Okay, so for the givens, especially for part A, okay, we're always going to have negative 9.8 meters per second squared for all of these problems, whether the thing goes up or down. We have time here, which is 4 seconds. And then because it's dropped, we're also assuming initial velocity is 0. Okay, and we are trying to find VF for part A. Okay, so then if you look at your note card, you're going to choose a formula that would let you solve for VF. So that one is actually simple because it's already solved for VF. Okay, because I know acceleration, I know time, I know initial velocity, and the only thing I'm missing is VF. Okay, so then plug in your givens. 0 plus negative 9.8 times 4 seconds. Okay, and if you're watching, you should do this along with me and make sure you get the same answers. So we're going to get negative 9.8 times 4 would give you negative 39.2 meters per second. But because of this number here, we only have 2 sig figs, so we're going to round negative 39 meters per second. And always at the end, you're going to ask yourself if it should be positive or negative. We got a negative answer, and that's actually what we wanted, because when we do these problems, we're saying that down is negative. And at this moment in time, the brick was falling down, so it should have a negative velocity. Okay, that was part A. Now let's do part B. So I need to stretch the page a little bit here. Okay, that's a little bit too far out. Hold on. There. Okay, so now it wants to know how far the brick has fallen. So we're looking for displacement. And we're looking for a formula. Now we have a lot of givens now because we also have final velocity. So there's a couple different ones you could use. I'm going to use this one off the note card. Initial velocity times change in time plus 1/2 a delta t squared. Okay. All right. So now we still have 0 as our initial. Okay. Um, okay, that's a lot. This goes all to 0. Okay, and then we get a negative number here. Yeah. So I get negative 78.4 meters. Okay. And then again, sig figs here, we're going to end up rounding to just negative 78. Because of that 4 seconds, it only has 2 sig figs. And is it okay that displacement is negative? Well, yes, because it fell down from where it started. So we're basically saying if this is 0 here, up where it started, okay, then it's fallen down below 0. So that's fine. Okay. Now let's do another type of problem where it's something that's thrown or kicked. So this is number 46 in your book. Okay. And it's talking about flipping a coin. And the coin's going to go up and come back down. Um, and I'm not a very good artist, but if we have, here's your hand. Okay. And you're going to, here you are. There's your leg. Okay. Wow, that's a huge hand. Okay, so you have a coin. You're going to flip it. It's going to start here, maybe. Okay. And when it leaves your hand, it's moving fast. And then it rises up to some peak. And then so it goes upward first. And then it comes back down and ends up back in your hand. Okay. Um, there's a trick that you use when you do these. Okay. So first of all, they're saying from where you threw it, it reaches a high point of 0.25 above there, 0.25 meters. Okay. Well, that's helping us because we're going to pause the problem. We're going to imagine you have a video recording of this situation. You would pause the video when the penny gets to the top of its movement, because also what you know about that moment is that its velocity right there is 0 meters per second. And that gives you another given. Okay. Um, and then you also know the displacement up to that point. So I know that it is going to fall back down, and so this is not really its final velocity, but it's okay to kind of hit the pause button, and the equations still work just fine. Okay, so what they're asking for, though, we have VF, that's 0. We have displacement for that part of the time is 0.25 meters. Now the overall displacement would be 0, right? Because it comes back to where it started, okay? But halfway through, it's 0.25 meters up. Okay, and then what was its initial speed? So they want to know VI, okay, which is not 0 this time. And then acceleration is still negative 9.80. Okay, so if we're going to find the initial velocity, we need a formula that has VF, delta D, VI, and A, and doesn't have time in it. So if you look at your note card, the best choice here is this one. Okay, so start plugging in. VF is 0 with this trick we're using. Don't know VI. A is what it always is. Okay, and D is 0.25. Okay, so then here, 0 meters squared over second squared. And this, okay, 4.9. I'm going to keep two sig figs. Okay, meters squared over seconds squared. All right. Well, oops, sorry, it's negative because of this negative right here in the A. Okay, well then that works out though, because you end up adding 4.9 to each side, which is good, because in this class we're never going to take square root of a negative number. If you ever start to do that, you know you did something wrong somewhere. Okay, last step, take square root, both sides. Square root of 4.9 gives us 2.2. Okay, and we're always going to ask ourselves, should it be positive or should it be negative? Because when you take the square root, there are two solutions. It could be positive or it could be negative. In this case, we want it to be positive because you threw the coin up, and up is positive in our reference frame. Okay, All right, so that's A. Okay. Now B, it says if you catch it at the same height as you released it, how much time did it spend in the air? There are a couple ways to do this. Let's extend the page actually. Okay. So if you are trying to find how much time now, okay, I'm going to show you two ways. One is you find the time it takes to go up and double it. Okay, that's one way. Or you could find the total time but remember to change your givens. Okay, so the first way, you just use the same givens as before. And the best way to do this one, I think, is just to use this formula and solve for time. Okay, so you still would say, well, at the top, it's going 0 meters per second. I now know that it was going 2.2 meters per second initially, plus negative 9.8 times delta t. Okay, and then you would go subtract from both sides, or however you want to do your algebra. This is working out well because I'm not going to get a negative time. That's important. Okay, and so then I think you end up getting like 2.3 seconds. Okay, but then that was really the time for it to go up, like, because remember we paused and did half of the problem. So then you'd have to multiply by 2 to get a final answer of 4.6. Okay. Oh, okay, hold on, girls. I've got the wrong numbers in here. I'm thinking of something else. I should actually solve it. So let's divide 2.2 over 9.8. That's better. I get 0.22. Okay, then multiply by 2, and you get 0.44. That's better. That's the total time. Okay, or if you just want to think about it carefully, really, for the whole problem, we said that the speed that something is thrown with, it lands in their hand at the same speed, only negative velocity. So you could change your givens and say, well, I know when you flip a coin, okay, it starts here, it goes up to here, falls back to my hand, and when it hits my hand again, it's going the same speed as it was when I threw it, but the other direction. That was in the notes, okay? So you could change and just say, let's do the final velocity, and that would be negative 2.2, just opposite of what the initial was, okay? And then you can do the same equation, but you'll get the total time and not have to double it. So then negative 2.2 equals positive 2.2 plus negative 9.8 times time. I ran out of space. Okay, and then you'd end up you'd get like negative 4.4 equals negative 9.8. Good. The negatives are going to end up canceling. T. Okay. And then when you divide this out, you'll get the same answer. You'll get 0.44 seconds. Okay, and there's a third way to do it also, like where you say displacement is 0 and solve for time. All those will work. Okay.